Hi everyone, welcome back to the channel, and today we'll discuss a very unique approach to solve a particular type of problems. And some of you may have come across this kind of problems earlier and solved in conventional manners, but we'll do it in a nice way today. And I'll also discuss the concept itself with the help of a little problem. And so first start with the problem, right? Let me write the question. Just I'm asking a simple one, that let's say this is a circle, or let me draw it a bit more accurately. This one is a circle and this is the topmost point of the circle. Let's name it as A, and this is the vertical line. Let's say shift this a bit. Yes, so this is the topmost point of the circle, and I'm drawing a chord which is passing through point A and reaching another point B, let's say on the circumference of the circle, and this chord is making an angle theta with the vertical. Acceleration due to gravity G is vertically downward. Acceleration due to gravity. And my question is, what is the time elapsed to reach B from A if a point mass starts from A with initial velocity 0? I mean, let's say there is you can assume like this, that AB is a rod and you are dropping a particle at A with initial velocity 0, then what will be the time taken? I think it's a simple question, though let me solve it first. G is vertically downward and its component will be G cos theta along AB, and G sin theta will be perpendicular to AB. So this is the acceleration responsible for the motion of the particle, and let's say this is the center of the circle. I'm joining this with B, CB. So from triangle ACB, BC is R, radius of the circle, and CA is also R, radius of the circle, and you drop a perpendicular from C on AB, you'll get this angle is also theta because ACB is an isosceles triangle whose AC and BC sides are equal. And after dropping the perpendicular, you can conclude that this length will be R cos theta, this length will also be R cos theta. So basically AB is 2R cos theta, right? AB is 2R cos theta, and I am applying S equals to UT plus half AT square formula. So as initial velocity was 0, this term will be 0, and S is nothing but the length AB, so I'm writing 2R cos theta equals to half. Acceleration along AB is G cos theta and time to reach B from A, it's square. Okay, so cos theta gets cancelled, and TAB comes out as root under 4R by G. So it's a very simple question, and solution is also very simple, but its application is huge. I mean, you can use this concept in some other problems as well, where it's not directly asking about this kind of a vertical circle and you find the time required to travel through a chord. They are not asking directly this property, but you can use this property. What's the conclusion from here? That if you take any chord that is passing through A, and you drop a particle with initial velocity 0 from A, it will take the same amount of time to reach another point which is on the circumference of the circle, and this is only dependent on the radius of a circle. So if you fix the radius, and you will get the time as a fixed one, right? So that's the conclusion, and that's the idea which we'll use in next problems. I have picked up 2 Pathfinder problems. Let's see one by one. I think I will cover one in this video and the second one in another video, otherwise it will get too long. So move on to the problem. This is the problem from Build Up Your Understanding from NLM chapter, right? So let me read out the problem once. A rigid triangular frame ABC made of a thin rod is fixed in a vertical plane. Angles between the rod segments at the corner B and C are 74° and 55° respectively. A small bead starting from rest from corner A takes equal time to slide down the arms AB and AC. There is no friction between the bend and the arms. Find the angle theta which the arm BC makes with the horizontal. So let me discuss the conventional approach once. What you could have done, that let's say this is ABC and this one is 74°, this one is 55°. So G is vertically downward, and you would have taken the components of G along AC and AB in different cases, right? When you are solving about AC, then equation will be AC into half acceleration along AC into TAC square. Similar one will be for AB, right? And as TAB and TAC are equal, it is given in the question. So if you take ratio of these two equations, divide one equation by the other, then there will be term AC by AB. You can relate this using sine rule, right? And AAC and AAB you can write in terms of G cos of the angle between G vertically downward direction and AC and AB in both the cases. So in this way you can calculate, you can calculate the theta, because acceleration will involve the terms theta. Okay, so let me denote the theta first. Sorry, I forgot. This one is the theta. So you can get the value of theta from here on, but I will not solve this problem in this manner. So let me erase this one, but this is the idea that you can follow, but I am not much interested in this one. So let me take a circle, this one, or yeah, okay, let it be here only. Let's say this is A, B, C. A is the topmost point of the circle. This one is, let's say, B. Okay, this was a bit tilted like this. This one is B, this one is C, and this is a horizontal line. This angle is theta, and we are supposed to find theta. Angle ABC is 74°, angle ACB is 55°. This is the center of circle. Let me mark it as O. And I am also joining all the vertices with center O. And this one is the perpendicular to horizontal, because I have assumed that A is the topmost point of this circle, vertical circle. So AO will be perpendicular to this line. This is the horizontal line as shown in the question. So this angle is 90°. And now move on to the triangle ABC. In triangle ABC is circumscribed by this circle which is centered at O. And from geometry you can easily notice that this angle is 148°. Why? Because angle ABC is 74°, so angle subtended at the center will be double as that at the circumference. So this one will be 148°. And if you concentrate on triangle AOC, this is an isosceles triangle where AO and OC both are the radius of the circle. So angle OAC and angle OCA are equal. So I can write angle OAC as 180° minus angle AOC, that is 148°, divided by 2. So this will come out as 32° upon 2, that is 16°. So this angle is 16°. Now I am interested in this triangle. In this right angle triangle, you just make the sum of the angles as 180°. So this will be 16° plus 55° plus theta plus 90° will sum up to 180° from this triangle, because sum of three angles is 180°. All of you know that. So this will come as 71 degree plus theta equals to 90 degree, or theta equals to 19 degree. Yeah, and this is the answer for this question. So that's how easily it can be done if you know the concept, I mean the technique that I have shown in this video earlier. That's why I like that idea, that this was a bit more creative than the conventional approach. I have no issues with the conventional approach. You must know the conventional approach for every problems, I think. But this kind of approach will always give you an advantage than the others. So that's all for today, and it's getting too long, so I'll cover another problem from MCQ section of Pathfinder NLM chapter only, using a similar concept. I'll solve that problem also in next video. Yeah, thank you.